Welcome to section 5, where we will talk about the closest pair algorithm. In this section, we will discuss the problem of finding a closest pair amongst a set of points and implement an efficient solution. In the first video, we will discuss the problem of the closest pair. First, we will introduce the problem through an example. Next, we will give a more formal definition of the problem. Finally, we will solve it using a simple, however slow, brute force approach. Imagine your job is to watch over a particular airspace and make sure no two planes come too close. Each plane is flying at the same altitude, so you only need to worry about their x and y coordinates coming too close. Using these x and y coordinates, you can find the distance between the 2 points. If the aircraft come too close to each other, you sound an alarm. The slight complication is that we don't just have one aircraft. It is a busy airspace with many planes flying around. Whatever algorithm we write to sound the alarm, it needs to be fast and be able to handle a lot of traffic. Our algorithm simply needs to accept a set of coordinates and calculate the distance between the 2 closest points. This is called the closest pair problem and is a type of a computational geometric problem. To solve this problem, we need a function. Let's call it closest pair. This function accepts an input containing a set of x and y coordinates. It then returns 2 points represented by the 2 x and y coordinates for which the distance is at a minimum. Before we can come up with any algorithm to find the closest pair, we need to figure out how to measure the distance between 2 points. In geometry, this is known as the Euclidean distance. The shortest distance between 2 points is a straight line between them. To understand how we calculate the distance, imagine drawing a right-angled triangle with the other 2 sides labeled as A and B. To calculate the length of this side, we just need to find the root of the sum of squares of the 2 sides A and B. Side A is simply x minus x2, and side B is y minus y2. If we substitute for A and B, we get the following formula. This is what we can use to measure the distance between 2 x and y coordinates. We can solve the closest pair problem by using a brute force approach. Let's pick an example to demonstrate this. In a brute force approach, we would start from a point, in this example, point A, and we calculate the distance between A and the next point B. Then we do A to C, A to D, and A to E. Then we move to point B and repeat the same procedure, skipping A. Then on to point C, always skipping the nodes already processed. Then finally, point D. We can skip point E, as we have already measured its distance to all other points. We then need to find the minimum of all the distances and output it. Let's now have a look at the pseudocode for this. We define a function taking in a coordinate set as input. We then initialize a variable called minimum to infinity, and initialize 2 coordinates that will hold the closest pair as null. At the end of our function, we return the pair. We create an exclusive outer loop, starting from 0 until the size of the set minus 1, and an inner loop from I plus 1 until the size of the set. At each iteration, we find the distance between the coordinate at I and j. If the distance is less than the current minimum, we record it as the new minimum and store the new closest pair. That's an easy way to find the closest pair by brute force. Unfortunately, it's not very efficient. In this video, we described the problem, explained how to measure the distance, and finally, we showed a simple solution using brute force.